including this one, just not these two designs. And then if you can do this, it's a little more complicated, it'll be like extra credit.
Yeah.
Okay. So this is like just a rough sketch of what it would look like. I drew two sizes as an example, and then you're gonna have two more that are just the exact same but smaller, right? So we have this first column will just be for the pixels, to make the pixel, and I would denote it, it's gonna be a positive resist. So you have this like outer and inner square. So I have like here the outer diameter being 420 micrometers and the inner diameter being 400, and then it just proceeds the same way. And then this one's 320, 300, 220, 200, 120, 100. Because the inner diameter is what the pixel is actually going to be. So we have a 100 micrometer pixel all the way up to a 400 micrometer pixel. This next column, which would be the next step, is after you have the pixel, you can put like a gold or just copper, whatever contact metal you want next. So that'll be this one. And so it's just literally gonna be a square because it's just gonna cover the whole pixel. But you're gonna leave a little bit of room on the edge, which is why it's 10 micrometers smaller than the inner diameter. Because when you have a pixel and you wanna put a contact on it, you have to line up that pattern. And if you don't line it up correct, like if you're just slightly off by even 1 micrometer, and say your gold contact deposits in the trench or like outside of it, then you short your device. And you need all of the contact to be within the pixel area, right? So that's why you make it a tiny bit smaller than the pixel. And then the last design for this device is for insulation. And so this is also a negative resist, and you're gonna have like an outer square that'll be where all of that insulation material goes, and you're gonna have these square openings to expose those contact pads. So the final device, if you do it right, would look something like this. This is just as if you only made 1 pixel. Obviously you're gonna have like a whole array of them, where your pixel is in here, this line here, and the gold is shown in the middle, but everything else is covered by insulation. So if you remove the insulator to get a better idea of it, it would be something like this. PBSE, in our case. Then you have this germanium substrate. So because we made the pixel, we etch away that trench in there to isolate this PBSE square right here. So that's the actual pixel. Then we have the gold in the middle, and then this would be the insulation like edge here. And then in reality, you're gonna have this insulation over it, and that would cover like all of this, so that everything's, so the substrate isn't exposed, and the sides of it can be like covered with insulation. But yeah, that's what the final would look like if you make it right. And so what you can do is when you make your when you finish with your design, it should look something like this, and you can check it to see if it all lines up. And you should do this throughout the process. Every time you do a new column, or like say you do the pixels and then you do the contacts, when you finish one, you should just check to make sure they line up perfectly. And you can do that by just copy, move it over here, and then copy this one and move it and see if it lines up perfectly, right? And then be like, okay, perfect. They're like perfectly spaced in there. See what I mean? Because you could accidentally have, say, one of these like that, and when you zoom out, you wouldn't know. You know what I mean? So yeah, if you were to check it, you'd move it here, be like, oh, it looks good. Oh, but you see something's weird with that pixel. And you zoom in and you see, okay, yeah, it looks funny compared to the others are nice and symmetric. You'd be like, okay, that one's like not centered. Something like that. But anyways, at the end, then you can say if you had fixed this, oops, When everything's good, then you can do the last one. Move that in there. And you should just see these concentric squares where this outer one denotes the outer edge of the pixel, like the where the trench starts, the etching starts. Here would be where you etched away to isolate this whole pixel area, right? Then you have the contact edge where everything in here will be with metal contact. And then this inner edge here, everything outside of that will be covered with insulation. And yeah, and I didn't have this outer ring, but you're gonna have an outer ring so that the insulation only goes to cover the whole pixels. But anyways, so this is a rough sketch. It's not to scale at all. But I gave you the dimensions, so when you actually do it, it'll be at the right scale. The extra credit thing is, if you have time, if you can make this. So most likely you'll only have room for 2, and you'll have to invert one of them. So you have basically a set of pixels ranging from big to small going one way, and you're gonna have to invert it to make space for the other one to go the other way. So that's for the pixels, and again, it's gonna be a positive resist. Then it's a simple contact for the negative resist. But what's interesting is all these pixels, you have like a big pixel here, a big pixel here, smaller, 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 all the way down. But you can have one contact bar that goes along the middle of them, but then just individual contact pads for the sides. So this one's cool because what you can do device-wise is you can, like, say bond a wire to the middle bar and just touch any one of these, and you'll be probing just that pixel. So they have like a common contact, but yeah, so just by touching this, okay, now I'm just observing this bar, or I'm just touching this, now I'm just observing this bar. So the tricky part is we want our pixel to be a square, right? But when you do this pixel, you're actually gonna have to make them rectangles, but once you do the contact on it, it should become a square. So again, this isn't to scale, so these still look like rectangles. But if I were to draw it correct, what you would want is, say you want like a 200 by 200 micrometer pixel, and you want your contact to cover probably 200 micrometers on either side. So you're gonna have to draw a 600 micrometer wide rectangle that's just 200 micrometers tall. So like, say the width will be 600, the height will be 200. Let's just zoom in on it. So you'll end up having a rectangle like this. That'll be the pixel that you etch. And then your contact bar will be, say, 400 wide and 300 tall. And 400 wide, 300 tall. And now only this area is exposed, and that area is the one that you want to be 200 by 200, right? So so the way you would actually draw that, like on a for your mask design, would be, the first pattern would just be this, the second pattern would be this, and when you combine them, it makes what we just saw, right? And you're gonna have like a whole row of those going from, and you may have to play with the sizes. I hope this fits, but if it doesn't, you can just adjust to as close as possible. The biggest one should be 1 millimeter by 1 millimeter, all the way down to 100 by 100 micrometers. And if you can, try to do 10 of them, so like every step. So 1 millimeter by 1 millimeter, then 900 by 900 micrometers, 800 by 800, all the way down to 100 by 100. If that doesn't fit, then just adjust it. If the 1 1 millimeter by 1 millimeter is too big, then start with 900 by 900 or something along those lines, okay? And we'll see if it works. You can always ask me for help, like, oh, if I want to make it this way, like, let me know and I can help with that. But as far as, yeah, also just a couple things to note that I'm writing here. This middle bar should be at least 250 micrometers wide, at least. And the same with all of these pads. Basically, they need to be around at least 150 micrometers wide and tall, because those pads will most likely like want to wire bond to, and that wire bonder tip is only like 100 micrometers in size. So anything smaller than that, we can't bond to it. So that'll be the limiting factor on how small you can make these contact pads. At minimum, each one of these pads here should be like 150 micrometers by 150 micrometers. Okay, and then this bar will be most likely at least 250 micrometers wide, and then just however tall it needs to be to encapsulate all the pixels, right? And how far you put in like this inwards like that to cover the sides, like that'll just depend on what this area you need it to be. And that's why this may need to be wider to cover like enough of the pixel to make it so that this area is what you want it to be. But anyways, again, this is extra credit. This is obviously more complicated than the other ones. The other ones are really, it's just a set of squares, different sizes. Most likely when you make these pixels, I'm not sure for the 400 because of the size constraint. Oh, and also I didn't put it on here, but don't forget you need alignment markers, which I showed you before, right? Yeah, you'll want alignment markers on each corner and then on each like side, in the middle of each side. And you want to put them really close to the edge. And but yeah, otherwise it's basically just concentric squares. And I forgot, let me say, oh yeah, the number of pixels is up to you, but basically this outer ring of the insulation layer will be the limiting area for where how many pixels you can fit. So this outer ring you can bring pretty close to the edge, but you want there to be a gap between here. And you can fit as many pixels inside of it as you want, but they need to be spaced enough so there's no crosstalk, like you don't accidentally like touch another pixel. So I would say the spacing between each of them should be at least a couple hundred micrometers. But most likely if you can get 30 pixels, that'll be good. So like or like 25 pixels or more. So like a 5x5 or more. So try for at least a 5x5. Like here I have a 4x4. Try at least to have a 5x5, and then if you can see how small of an area that takes up here, and if you have more room, just make more. Okay? Yeah, so that's it. So I'll go ahead and email you this, and you can start working on it. And if you have any questions, just let me know.
Okay.
Cool.
Thank you.
Thank you.